Okay, let's do problem 12, 170. So here we have a boy who is on a rotating disc, like a merry-go-round, and he's running from the center straight out. Now, if you're on a merry-go-round and you didn't see the world around you, you may not really realize you're rotating, besides the fact that you might be throwing up. So, if you start here and you run straight out, oblivious to the fact that you're rotating, R is the same thing as X. So we can write, instead of the equation X equals 1/2 AT, right, we could write that equation R equals 1/2 R double dot T squared. Okay? And instead of the equation V equals AT, we can write the equation R dot equals R double dot T. Okay, and then this says at the time when t equals 3. So therefore, we can plug that into these two equations and have the solution for R dot, and R double dot, because he's doing it with a constant acceleration of 0.5. So R is equal to 1/2 0.5 3 squared. R dot is equal to 0.5 T, and we'll just write for sake R double dot equals 0.5, as is stated right there. Oh, not T. 3. So this one is equal to 2.25 meters, and this is equal to 1.5 meters per second, and R double dot is meters per second squared. The platform is rotating at a constant rate of theta dot equals 0.2. So theta dot equals 0.2 radians per second, and it was rotating at a constant rate. Therefore, theta double dot is 0. And then we use the equations for radial and tangential velocity, or transverse velocity, acceleration. So the radial acceleration is R double dot minus R theta dot squared. The tangential acceleration is R theta double dot plus 2 R dot theta dot. So just plugging in the values for these things, we have 0.5 minus 2.25 0.2 squared, and that equals 0.41 meters per second. And this one is equal to 2.25 times 0 plus 2, 1.5, 0.2, which is equal to 0.6 meters per second squared. And that is the transverse acceleration and the radial acceleration.